This is the final video lecture for Chapter 4, and that doesn't necessarily mean that it has to be watched last. Throughout this lecture, I will go through how to solve problems of different types that we will encounter in this class and throughout the year. An object is in equilibrium when the velocity is constant. That merely means that the acceleration is zero. Therefore, you could have some velocity, for example, a skydiver falling at terminal velocity very fast, or something sitting at rest on a table. Both of those objects would be in equilibrium. When looking at forces in two dimensions, make sure that the net force in each direction, x and y, is zero in order for equilibrium to occur. An example of someone getting pulled behind a boat on a water ski, when they're just floating in the water and not moving, they're at equilibrium. The net force on them is zero. When they are accelerating, getting pulled up out of the water and accelerating forward, their velocity is increasing. They are also, at this point, not at equilibrium. Finally, once they reach their cruising speed or cruising velocity, and as long as they are not changing direction and their velocity is constant, then they are once again back at equilibrium. In this case, in the final situation, when this girl lets go of the rope, she slows down. Her acceleration is in the negative direction. Her velocity is decreasing. Once again, she is not in equilibrium. Equilibrium is when the net force on an object is zero. Whether solving problems big or small for forces, you should probably always follow these steps. First, select your system or object. In this case, you want to pay attention to Newton's third law and which forces are acting on which objects. Second, draw your free body diagram or FBD. Make sure to have a single point for each object and start each arrow from that point. Third, choosing your axes. Whatever works, make it easy. That's the big thing here. If it's something is at an angle and you have something else on the horizontal axis, find the components first. Step 4 is pretty straightforward. And step 5, solve out whatever you need to know. This usually includes finding the net force from each component direction. All right, let's look at a practice problem. Here we have a jet flying through the air in equilibrium. The important thing to know right away, by the fact that it's in equilibrium, is that the net force on this jet is going to be zero. T stands for the thrust of the jet, that's due to the engines. W stands for the weight of the jet, due to the force of gravity. L is the lift the jet generates on its wings, holding it up in the air. And R is the resistance force due to air resistance. So now you need to go through and figure out, first set up and draw a free body diagram. Part of it's already done for you here. And then you have to solve out the equations, solving for both the lift and the resistance forces. Here are the values for both the thrust and the weight that you will need to solve for the missing forces. The thrust, T, is 103,000 newtons. The weight, W, is 86,500 newtons. The lift, L, is going to be balanced out by part of the weight. R, the resistance force, is going to be balanced out by the thrust. But in addition, there's also some component of the weight acting opposite the thrust. Following our steps for this problem, the object is the jet. That's pretty straightforward. Now you need to draw a free body diagram. It may actually be helpful to first orient your axes before you do that drawing. in this situation, looking at the bottom of the previous pictures that we've had, the X and Y axis are rotated to follow along so that they are parallel to the thrust and resistance in the X direction and the lift in the Y direction. This just means that we have to find less components in each one of those directions for all the individual forces. The only component that we need to really determine the parts for is the weight. Now you need to ask, is it accelerating? No, it's in equilibrium, so there's going to be no net acceleration. Finally, you need to solve for both the resistance force and the lift. Please take this home and do this in your notebook. Show your work. Draw out your free body diagram. Go back in the video and look through at the other drawings and the other steps to follow through. Please make sure you bring that to class on tomorrow. Thank you very much. Have a good night.